Right. So this is the second view. This is the continuation from the last week. Last week we started with hypothesis testing. We talked about hypothesis testing, right? In the hypothesis testing, two things we learned: how we can develop a null hypothesis, how we can develop the alternative hypothesis. So how the null hypothesis and the alternative hypothesis can be developed, right? First, we have to develop the null hypothesis. For developing the null hypothesis, I set a rule. It is referring the reference population. Null hypothesis formulated based on the reference population, where the mean is known. So keep that in mind always, where the mean is known, referring the reference population. The alternative hypothesis, by looking at your null, it has to be mutually exclusive statement, whereas you'll have to think little on your objective also, objective or aim of the study, etc. So based on the objective of the study, you have to formulate your alternative hypothesis. Okay. So that is how we formulate our null and alternative hypothesis. Null and alternative hypothesis. Right. Okay. We are going to talk about one-sided and two-sided hypothesis. Right, one-sided and two-sided hypothesis. Look at here the distribution. Take only one distribution. This is the distribution that we are talking about. So if you look at this distribution, right? If you remember last time, which error is more important among two errors? The most important error is anyone? When we do our yeah. We concluded that this alpha error, or we call it as type 1 error. So whenever do experiment, we concentrate more on type 1 error. When we consider the error as it is, that doesn't mean we don't consider beta. We consider beta by other ways. What are the other ways to consider beta? Increase the sample size, which I said last time, and also selecting a good experimental design. Right? But when you consider the alpha, right, because this is the most important error, alpha error, or type 1 error. This type 1 error can be demarcated in both sides, because this is in a T distribution. This is a T distribution. Can you remember T distribution? We talked about T distribution, right? In T distribution, T distribution is a symmetric distribution. In T distribution, we can consider both sides. So it is called as two-sided. It is called as two-sided. Similarly, we can talk about one side. So if it is two-sided, this is 1 minus alpha. This area, unmarked area, is 1 minus alpha. So what is the area of each of these? Because it is symmetric. Can somebody tell me what is the area of this? What is the area of
alpha over 2?
Yeah, alpha by 2. So this area also alpha by 2. Because we have one alpha, but we have demarcated in both sides, which is symmetric. So we can say alpha by 2. Now, this is one situation where we call it as two-sided situation. The other one-sided situation. So in one-sided situation, we can have two ways. Look at it is a one side. The whole alpha is concentrated on one side. So here this is right side, isn't it? This is right side. What is the shaded area? What is the shaded area? Here it is alpha. This is 1 minus alpha. Shaded area is alpha because it is not shaded in both sides. It is on concentrated on one side. So this is one side, but which side is that? Right side. What about this then? Shaded area is alpha. This is 1 minus alpha. So how would you call this particular distribution? This is one side, definitely. Left side, right. Right. Now you understand this is two-side situation. These are one-side situation. Now we want to see during which time, which occasion we can use this or this or this. We can't use everything at once in an experiment, right? In a trial, we can use this one, or this one, or this one. But it depends totally on what we are going to test as an alternative hypothesis, right? Somebody asked before starting the lecture, so we are coming to that. Right, now, if my null hypothesis is mu equal mu naught, so mu naught means it is the mean value of the reference population. It is the mean value of the reference population. This mu naught is the mean value of the reference population. Write it like that. Mean value of the reference population. Can you remember last time what was the test that we have used to test Jaffna district? Mu equal, I couldn't remember the value. Mu equal
4.
4. Right. Last time we took it as mu is equal. What is the average mean of Kurnagal district? 6. Is it 6 or 5? 6. Average mean of
6.
Kurnagal 6. Right. Okay. So can you remember last time we took to test whether this particular group of farmers, whether they are coming from Jaffna district. So my null hypothesis mu equal 4. Same as this is mu equal mu naught. So these are in a general term, right? This is the mean of the reference population, right? Same as this, right? Now, if my objective is, if I say in a question, in an objective, test whether these farmers are coming from Jaffna or not. We don't care about whether they are coming from Thoothukudi or wherever it is. Doesn't matter. So we want to test whether this group of people or group of farmers, whether they are coming from Jaffna. That is all I want to test. Is it clear? I want to test only whether the group of that people are coming from Jaffna. That's all. That is all my duty in terms of research. So if it is so, my null hypothesis is mu equal mu naught. Alternative is not equal to mu naught. So in other term, in our previous example, mu is equal to 4. Mu is equal, sorry, not equal 4. This is what we want to test in our last week example. We want to see whether it is mu equal 4 or mu equal, sorry, not equal 4. So my question or my objective is test whether these farmers are coming from Jaffna or not. That's all. I didn't ask rest of the question, whether these farmers are coming from Jaffna or not. If I want to analyze or if I want to test that statement, this is the way that I formulate the hypothesis and the alternative hypothesis. Null hypothesis and alternative hypothesis. Right? Now, look at here. Right? Here, if mu is not equal to mu naught, what are the possibilities? What are the possibilities? One possibility is mu can be greater than mu naught. If I accept my alternative hypothesis, one possibility is mu could be greater than mu naught. The other possibility is mu could be less than mu naught. Do you agree with that? If I accept this, if we say this is not equal to that, then we would say mu could be greater than mu naught or mu could be less than mu naught. Do you agree with that? Yeah?
Yes.
Right. So if we accept this statement only, this is true. If we accept that statement, this is true. Either this is possible, this is possible. So look at here in this distribution. Right? This is my mu naught. You can indicate as mu naught. This is mu naught. It is the average value of the reference population. Right? Now, you see, this is mu not equal mu naught. So, what side that you are talking about? Whether it is left side or right side? Look at this. So, I said mu greater than mu naught. One possibility, mu less than mu naught. If it is greater than mu naught, what side is that? If mu is greater than mu naught, which side are we talking about? Left side or right side?
Right.
Yeah, mu greater than mu naught. What side is?
Right
mu?
side.
Which side? I couldn't hear properly.
Right side.
Right side. Good. You see, our mean that we are testing under the testing is greater than the mean of the reference population or higher than the mean of the reference population. So this indicates the right side. How about this one? This indicating the left side. So here it includes both left side and the right side. Is it clear? It includes, if you say mu not equal mu naught, that means it is include both sides. In other term, it include two-sided test. So this is called as two-sided test. Two-sided test. Here we are talking about one-sided and two-sided test. So it is called as two-sided test. So if it is two-sided test, this is how the picture is. We can have our alpha on both ends, both tails, two-sided, right? Right. Last time we took an example, other example, not rice. Sorry, not paddy. I took some other example. Can you remember? What is that?
Tilting one.
Yeah.
Irrigation water.
Yeah, that is the, how do you call, EC, electrical conductor, right? electrical conductivity, we said that if the null hypothesis mu equal 3 micro Siemens per centimeter, something like that, right? So if it is equal to 3, can we irrigate this water? Can we irrigate this water?
Can't.
No, sir.
So 3 is the maximum possible. I mean, 3. If the electrical conductivity is equal to 3 of a water, that means that water cannot be used anymore for irrigation purpose, right? That water can be used for further for irrigation purpose. So, what is my test? Whether this water can be irrigated. So that is my objective. Test whether this water can be irrigated. So what is my alternative hypothesis? Null hypothesis is correct. What is the alternative hypothesis? If it is equal to 3, that means water cannot be irrigated. The alternative hypothesis should be opposite to this. Water should be able to irrigate. If water should be able to irrigate, the electrical conductivity should be
Less than 3.
less than 3, right? It should be less than 3 because the electrical conductivity, if it is equal to 3, then we cannot use, I mean, that water for irrigation. That is true with any value above 3. Why? If the electrical, we said the border is 3. If the water has 4, 5, 6 electrical conductivity, still they cannot be used. So that means here in this case, this can be set as mu equal 3, that is also possible. Mu greater than or equal 3, that is also possible. So by word, we understand any value of 3 and above, we cannot use that water for irrigation. Clear? Right. Now alternative, we said mu less than 3. So if you look at in this format, so this is null hypothesis mu equal mu naught, right? What is the alternative? Mu less than mu, isn't it? Mu less than mu naught. Now, which side you will choose? Whether this side or that? Mu.
This side.
Yeah. You will choose this. Why? Because we say our mu is less than mu. So this is a left side situation. Right? This is a left side situation. I will give one more example. I will erase this. Right. This is a left side situation. Left side test. We can say left side hypothesis test. We have a small board, so I like to erase all the time. Right? Right. Now, I have another example. Let's say our national paddy production is 4.4 metric ton per hectare. Average paddy production of national level is 4.4 metric ton per hectare. Now, I have a set of sample. I want to test if the question like this. Test whether this group of sample or group of farmers are having average paddy yield above the national average. Test whether this group of farmers having the paddy average above the national average. Right. So this is the question. So what is how I can formulate my null hypothesis? Null hypothesis is simple. Mu equal mu naught. So in other term, what we say is mu is equal 4.4. So that is what we are saying. It is equal as national average. Look at the sentence carefully. The question carefully. You were asked to test whether this group of farmers having the average paddy yield above the national average. Above the national average. So you want to test whether this group of the average of this group of farmers above the national average. So in that case, what is your alternative hypothesis? Above the average. So mu is more than mu naught. That is what you want to test. So another term, alternative mu greater than 4.2. Do you get the concept here? Do you get the concept here? So it's totally dependent how the alternative design or alternative hypothesis formulation is totally dependent on our objective. So I can ask the question in such a way we can have different set of hypotheses. So earlier I have shown you how to talk about two-sided. Then we talked about one-sided, the left side. Now, what is this side? Mu greater than mu naught. So here, mu in this case, mu less than mu naught. Is it? Mu less than mu naught mean it is left side. Here, what is happening? Mu greater than mu naught. So that means it is on the right side. So this is the right side. Yes. So whether it is a two-side testing, right side testing, or left side testing is totally depend on how do we ask the question. How do we ask the question? Is it clear? Somebody asked question in the morning. Lavanya. Oh, I couldn't remember the name. What is the name? Ask question in Tamil.
Yes, sir, I understood.
You understood. Right. So now you see whether it is a left side or right side, or whether it is a two-side, is totally depend on the way that we ask the question. We can't ask the question always in a similar way. We can ask questions in different ways. So in this case, we said test whether the irrigation water can be used. I mean, that particular water source can be used for irrigation. So this is how we like to test it, because if we can't test more than 3 here as already. This is the value of the reference population. Reference population says that we cannot use if it is same as reference population for the irrigation. So it should be less than. So in this case, other way more than 4.4. We want to test whether this group of farmers is having average more than the national average. Then we can have this kind of setup. We'll see 1 or 2 examples later on how to do it. Right? So this is called as one-sided, two-sided hypothesis testing. So imagine this is the T table, right? Make a note of it in all cases. Right? I will erase this. Now this is the T table. Okay. We convert this into T distribution, right? So this is not real T distribution. This is the normal distribution or the sampling distribution. So we will convert this into T distribution. In T distribution, based on our calculated value, if the calculated value is greater than table value, If the calculated value, I will write it here. This is for two-sided. If the calculated value is greater than the table value, we reject our null hypothesis. Why we say we reject our null hypothesis? The shaded area are called as rejection region. These are called as rejection region. Right? These regions are called as rejection regions. Right? There are two rejection regions when you have two-sided test. When you have one-sided test, you have only one rejecting region. So this is on right, this is on left. We will see that with the example answer. So the decision-making process for the rejecting of null hypothesis, if the calculated value is greater than the table value, they reject it. Can you see this kind of parenthesis? What is that? What do you mean by that? Can somebody tell me? You might have seen this kind of parenthesis earlier. What is that? Yeah? Anyone? So this is called, have you seen in mathematics? They basically write like this. Have you seen that?
Mod values.
Yeah.
Mod value. Always plus.
Yeah. How do you call this?
Mod values.
What values?
Mods.
Okay. I don't know how to do that. It is called as absolute value. What do you mean by absolute value? What is the absolute value of -3?
Plus 3, sir.
Yeah, it is 3. This is called as absolute value. Absolute value is without giving the sign, right? So this is called as absolute value. So here, the absolute value of TC or T calculated value should be greater than the absolute value of T table. Why? Can you remember what is the minimum and maximum value of T distribution? What is the mean value of the T distribution? We talked about T distribution. What is the mean value of T distribution? Not last week, week before that. Better to not to put down chat because I like to open.
0, sir.
Yeah, 0. Yeah.
0, sir.
Yeah, 0. Don't put it on chat. No. It is 0. In a T distribution, the mean value is 0. What is the maximum possible value and minimum possible value?
+4 and minus.
Yes, minus infinity and
Plus infinities.
plus infinity. By theoretically, that is the value. By theoretically, minus infinity to plus infinity. Right? Right. Now you see, since we talk about 210, any value less than 0 can be minus value. Any value more than 0 could be plus value. So that is why we have put this absolute value terms. Okay. Right. I will erase this. I need to erase the other components also. Right. Right. Now let's come to the second right side. Right side means the rejection region. If the calculated value is greater than the table value, right? Not in terms of absolute value. Why? It is on the right side. Always it is positive value. We reject or so that is the case for the right side. Can somebody tell me what is the situation for the left side? If the T calculated, right?
It's less than
Is that correct? Normally T table we read it always positive value. Always positive value in T table. Don't forget. So here how we write. Always T table is a positive value. So we can say if the T calculated absolute value, T calculated value will be minus value, right? Usually it will give minus value. So if you take the absolute value, if it is greater than table value, right, then we will reject one. Okay. Normally, let's say my table value is 2.3 as an example. 2.3. My calculated value is minus 2.8. So what about absolute value of this?
2.8, sir.
Absolute value. Than this. So therefore we can reject on null hypothesis. So we'll take a couple of examples and do it, right? So that is how the decision making process takes place. Right? Right. Any questions? So this is called as one side and two side situation. As I pointed out, this one sided and two sided, we can have it only once. I mean, we can't have all three together in an analysis. We can have this or that. It depends on our objective or the question, right? Right. Okay, that is the about one-sided and two-sided. Before we do an example, concept, right? One more concept. We will see with an example later on, right? Anyone is having last year question paper? Anyone is having last year question paper at the moment? Yeah. Do you have the last year question paper?
Yes, sir.
Can you, not now, we will do an example. We will, can you just photo and WhatsApp it to your friends? And then you'll have to dictate to me so that I will discuss that question on the board today. Right. Confidence interval. Confidence interval approach hypothesis testing. Who answered me? There was a question on the question paper. Who spoke to me?
Aroshas.
Aroshi, right. Aroshi, can you, what is the first question? Do you have the question paper? That is about what?
Salinity level of irrigation water.
Right. Take only one question. Huh? I mean, don't copy others. Others are, we are not going to do it now. Just copy only question number 1 and pass it to your colleagues just now. Then we'll have to dictate, not detail, but dictate so that I will do that question on the board, right? Okay, right. After this concept, confidence interval approach for hypothesis testing. What is confidence interval approach? Usually, if you have a population, as we said, my reference population mean value is mu naught, right? Reference population mu naught, mu is equal to mu naught. Suppose, let's say my null hypothesis mu is equal to mu naught, right? Alternative, mu not equal mu naught. Can you remember the two-sided test that we have talked about a few minutes ago? The same thing, same null and the alternative hypothesis. So here we can have a confidence interval where this is called as the lower limit, this is called as the upper limit. Suppose, let's say this is 95% confidence. Right? If this is 95%, what is these percents? Symmetry. Can you all recall? What is it?
2.5, sir.
Yeah, this is 2.5%. This is 2.5%. So when I say my alpha is 0.05, this is in probability. If you convert that into percentage, you simply multiply by 100. So alpha is 5%. 1 minus alpha is 5%. 1 minus alpha is
0.9995.
yeah. I mean, in percentage, if alpha is 5%, what is 1 minus alpha?
95%.
95%. So you see, this area covers 1 minus alpha, which is 95%.
95%.
Yeah, 95%. So this is 95%. So this, as an example, if the alpha is 0.05, the lower limit and the upper limit, which covers almost 95% of the data. 95% of the data, or the farmers, or the population, whatever it is. So this is the lower limit, this is the upper limit. The rest, 5%, in this case, 2.5% on the left side and 2.5% on the right side. Okay, so this is what we call as confidence interval. So the confidence interval, there is a formula for that, right? Is based on estimate. Confidence interval is based on estimate plus or minus t table value, which is having alpha by 2 and degrees of freedom n minus 1, right? Alpha by 2 and n minus 1 degrees of freedom. How to look at the table, we will see that later. Into standard error of estimate. Standard error of estimate. Right? Standard error of estimate. So that I'm writing in the up. So that is further confidence interval is equal. Estimate means is the x bar plus or minus. We have the t table, t alpha by 2 n minus 1 into standard error of estimate, that is s divided by square root of n. You might have seen this is standard error of estimate earlier in the Z transformation. We talked about this, s divided by square root of n. So this is the formula for the confident interval. That is the formula for the confident interval. Okay. So this confident interval will have upper limit and the lower limit. So you see here we have plus and minus. So this is upper limit. I mean upper limit will come with the plus. For example, x bar plus t alpha by 2. I will write this. Right. The upper limit, I will say x bar plus t alpha by 2 n minus 1 into s divided by square root of n. So this is the upper limit. The lower limit is x bar minus t alpha by 2 n minus 1 into s over square root of n. So this is the true mean difference, or we can say the mean confidence interval of true mean. Confidence interval of true mean can have a range of value upper and the lower value. I will take an example. Let's say our paddy production in Sri Lanka. Paddy production in Sri Lanka. Let's say my upper limit, and let's say this is 95% confidence interval. 95% confidence interval. The value is, as an example, between 3.2 to 5.8 metric ton per hectare. So what do you mean by this? What do you mean by this? This is 3.2, this is 5.8. This area is 95%. Because my alpha is 0.05. My alpha is 0.05. We do the calculation, we will see that later. Now, after doing the calculation, we come up with two values. One is the lower value, this is the lower value, 3.2. And the upper value, it is 5.8. Where we can say the true mean value of the mean value of what? True mean value of the paddy production of Sri Lankan farmers, paddy production of Sri Lankan farmers, that we are 95% sure, right? We are 95% sure that the true mean production of paddy farmers range from 3.2 metric ton per hectare to 5.8 metric ton per hectare. That means I am almost 95% confident that the farmers in Sri Lanka are producing the average paddy yield in between 3.2 to 5.8 metric ton per hectare. So that is how we interpret. We will see this later with an example, right? So this is how we define the confidence interval, right? Right. Any questions on what we have said? Now we are going to do a small exercise from the last year exam. Right, Arosha, now it's your turn. you can summarize the information to me so that I will make a note of it. Then we will do that. So, yes, Arosha? Arosha, are you around?
Yes, sir.
Yeah. Have you sent all these questions to all your colleagues?
Yes, sir.
Yeah. Okay. Good. Right. Everybody need not to write down this question. That is why. So everybody can see the question directly. So what is the stem of the question? Before asking the part one, part two, just tell me the question. Read the question.
Randomly selected water samples were recorded.
Okay.
Electrical conductivity
Yeah.
2.8,
Values. I will write down the values. 2.8.
3.1,
Yeah.
2.8,
Okay.
2.9,
Yeah.
3.0,
Yeah.
2.7, 2.6, 2.7, 3.2, 2.9.
Right. It is on the board. See whether all values are correct. Right. Okay. You can continue.
If the EC content of the water is more than 3 decisiemens per meter, it is not so. Sorry,
More than 3 or equal to?
more than 3.
Okay.
Not suitable for irrigation. Test whether the water could be used for irrigation purpose using alpha equals 0.05.
Okay. So here what we say is normally there's a statement. If the EC, right? If the EC is more than 3, then this water cannot be used for irrigation, right? If EC is 3, we cannot use this for irrigation purpose, right? Right? Is it clear? Okay. Any questions? Is there any follow-up or questions along with that, or is that only the question? Rosha?
Yes, sir. That's all.
That's all, right? Right. So you have taken, randomly taken a sample of 10 is given there. Yes, 10 sample given there, water sample. We want to decide whether this particular water is useful for irrigation. One clue is given, the standard for saying this irrigation water to be, if the irrigation water to be more than 3, right? If it is irrigation water is more than 3, then we want to say that it is not suitable for irrigation. If it is less than 3, yes, it is good for irrigation. Is it clear? Right. Now, there are few steps involved, 4 steps involved. Don't forget, in this, even though the question is very simple, there are 4 steps involved. You get marks for all 4 steps. Right? First step is formulating hypothesis. Formulating hypothesis. So that is the first step. We'll have to formulate the hypothesis. What is the hypothesis now? What is the hypothesis? Can somebody tell me what is the null hypothesis? What is the alternative hypothesis? Any question?
Null hypothesis, sir. H naught is equal to H naught is equal to greater than equal 3.
we'll have to put a sign mu, mu, because that is we don't know the mean value of that. So the assuming that mu is from this our population, from the sample population, this mean. So mu is equal or greater than 3. So it is same as the reference population mean, same as the reference population. So that means if it is equal to 3 or greater than 3, we could say that is not good for irrigation purpose. Is it clear? The alternative definitely less than. Is it clear? So this is the first step that you'll have to formulate null and the alternative. So this is last year question. So you can ask any questions on this. Otherwise, we will go to the step 2. Anyone? Step 2, test statistics. Test statistics. So test statistics is based on formula calculation. So T calculated value is the X bar. I will give the estimate minus null hypothesis value, estimate minus null hypothesis value divided by standard error of estimate. Standard error of estimate. So you don't need to write always this is in the exam. I'm just giving you to understand what are the components coming when you do the test statistics. This is the T calculated value. So this is called as TC, T calculated value. Right? So it is further continue. TC is equal X bar minus hypothesis value divided by standard error of estimate. So this is how we write the formula. So this formula you should remember. That is the conversion. Can you remember we have done some conversion or Z conversion? Can you remember 2 weeks ago we talked about normal distribution can be converted into Z distribution. Here actually the sample distribution is not really normal distribution. Right? It is a symmetric distribution, but it is not a normal distribution. Right? Can you remember? This is a sample distribution. So that distributed, if the sample size is small, it is distributed as T distribution. This is distributed as T distribution. That is why we are using T distribution for transformation of the calculation. Right. Now, what are the node factors here? Can you tell me what is this? What is this? Have you never seen some similar to this before?
Sample means, sir.
Right, sample. So here we have the sample. So we can get the sample mean. Okay. What is this X naught value? Hypothesis, null hypothesis value. What do you mean by this? We are going to test against a particular value. What is that against value here in this example? Null hypothesis value. What is the null hypothesis value? 3.
That's 3, sir.
3. This value is 3. Null hypothesis value is 3. So then divide by what is this S? What is this S? Anyone? First lecture, second lecture, evaporated. What is this S?
Deviation, sir.
What is that?
Deviation.
Deviation. Look back to your first or second lecture.
Standard deviation, sir.
Yeah, sample standard deviation. This is sample standard deviation. N, we know what is the value. What is the N? Number of samples. How many samples are there? 10. N is 10.
10 samples, sir.
Right. Can you calculate this X bar and S and tell me what is the value? Tell me only one value. Huh? So you have how many people? 30, 60 odd people are there. So don't tell 60 odd different values for mean and the standard deviation. So I cannot calculate them. So we'll have to tell one answer for mean and the standard deviation. Calculate and see. Without that, we cannot proceed. So I need the answer. I will ask question from everybody to give the value for standard deviation and X bar. Do our reps here, both Jeffrey and Kamsatvani? Are you all around?
Yes, sir.
Good. What about Jeffrey? Jeffrey, are you around? Any value of X bar? What is the value for X bar?
2.87, sir.
Point
87.
right. About the other informations. S, standard deviation. That take a little time. How many of you have scientific calculator? If you have scientific calculator, you can calculate very quickly in a couple of minutes, less than a minute. Anyhow, we'll have to calculate the standard deviation. Otherwise, we cannot proceed. So everybody should know how to calculate standard deviation. If you are unable to calculate the standard deviation, no point of giving a BSc in agriculture degree. Right? So everybody should know how to calculate standard deviation. Were you able to screen all my presentation or? Any problem with the lectures in retrieving from the link? All are busy with calculation. Yeah, I understand. Jeffrey, are you around? Amsathani?
Sir.
Yeah. உங்களோட கிளாஸ்ல பிசிக்கலா எத்தனை பேர் டோட்டல் அட்டெண்டன்ஸ் விட்டுட்டு போனாங்க இல்ல ஜெனரலா எத்தனை பேர்
85, sir.
85.
Yes, sir.
Right. Do you know what is the reason why others are not coming into lectures? Any reason? Yeah, one or two has called me.
Yes, sir. 2 students have network problem.
Yeah, from Abhisavale or somewhere. One student called me. But any idea about others? Since Kamsatvani, better to put since you are there, put information to all your batchmates since you are the batch rep, right? Second batch, batch rep. I requested them to follow. I mean, people who have network problem, let it go as it is. We will find some solution. But because, as I pointed out, the attendance is important. Huh? So if you don't have attendance, this is like a remote studies. We are also giving the degree online degree. That is also possible. No? This is not an online degree. Don't forget arrangement to cope up with the present situation. That is why we are giving online lectures. So attendance, if anybody having poor attendance, will have, because I am the only one teaching this course, so I have full authority. So if you don't have attendance, you will be in trouble. So ask them to attend the class, because we can take the attendance because it is in our account, because it is coming through our account, so that we can get the attendance. I don't know whether I showed you. Did I show you last time how the attendance comes? Amsathani, நான் சொன்னேனா last week?
Yes, sir.
Right.
Oh, yes, sir.
I showed you your name, then email address, and how you all are logging at the time of logging and time of logout, the duration of logging. So all this information comes. So you can't. I mean, this is a computer output. You can't change because so we'll have to submit all this to your quality assurance cell. So it is important. Right. Anyone calculate the value? This is the first lecture, I think, calculating variance, standard deviation. So you can't calculate the standard deviation directly. You'll have to calculate the variance first. Then take the square root of variance, which is standard deviation. Arosha, did you did?
No.
Anyone did the calculation, standard deviation? Because without that, I don't have a calculator to calculate the standard deviation. So you'll have to calculate and tell me exactly what is the value. Otherwise, I cannot proceed. I didn't bring my calculator. I cannot use the computer also because I cannot reduce this. Otherwise, it will get disconnected. Who else is there? Value? Harshika? Yeah, some values are there. Some values are there. Yeah. Can somebody put some the values? Then I will see whether I can take this value without telling. One person has sent the value, but I want to cross check whether this value is the correct value. So one or two other people can send me the value. Yeah, it is also closer to that. Good. One more. Zero point. Suvanya, Aradhana, any value? You can send it to me. Sri Divagaran, Sindhujan, if you are unable to send, talk, just send the value via chat. Kirija, no one has done then, huh? Only one, two people have done. You can send me through chat. Yeah, no one is responding. So I will take this as 0 point. I don't know actual value. 189. Because there are different values. Yeah, because one says 0.187, the other one is says 0.1886. The third one says 0.1957. So there are three different answers, I said. So all three are, closer, but three different answers. Now both answers also coming, like election results. 0.186. So right, we will stop with that. So get at least because such a small value, we'll have to have 2, 3 decimals. 3 decimal is good enough, right? Let's assume this is the value. Now you calculate the value. You calculate is 2.87 minus, right, 3 divided by 0.189, whole thing divided by square root of 10. Square root of 10. Right? So this is 10. Square root of 10. Right? The last one is square root of 10. Get me that answer. Somebody get me that answer. Get me the answer. Anyone? What is the answer? Anyone? What is the TC? T calculated value. So you see here, it is coming in minus. Plus or minus? Minus, yes. Not plus, because this 2.87 minus 3. So here it is minus already. So it can't be plus. So minus 2.175. I will take 175. Minus 2.175. Can you remember we said about our null hypothesis? Look at the alternative hypothesis. It is the left side. Is it mu less than 3? Mu less than 3. Right? The alternative hypothesis is mu less than 3. So mu, let's say mu naught, which is let's say 3. The mean value is 3. So our mu is less than 3 mean it is the left side. Right? We talked about left side and right side distribution. Right? So here it is left side. Right. This is my calculated value. Now I'll have to take the table. To take the table value, we need two information. One is alpha. Our alpha, let's assume this is 0.05, and the degrees of freedom. What is the degrees of freedom? N minus 1. The degrees of freedom is N minus 1. So in the T distribution, right? T distribution. Here we have the probability P value. Here we have the degrees of freedom. So what is the degrees of freedom? 10 minus 1, which is 9. So along this 9, we'll have to look at the table value. So how to look at the table value? So this particular table which you have already is a table which is giving the T value for two-tailed situation. The table which is having with you is giving for two-tailed situation. That is why here it says, right, you can see here, it is given there. It is given for two-tailed situation. If you are going to look at for one-tailed situation, here we have one-tailed situation, we'll have to multiply the alpha value and look at for this table value, because this table is designed for two-tailed. My alpha is 0.05. If I want to look at this alpha value for a table which has been designed for two-tailed, we'll have to multiply the alpha and look at the table. That is just an adjustment to read the table. Nothing to do with our alpha. So just look at the alpha, multiply by 2 and look at the table. So what is the P value that I will look at it if my alpha is 0.05? Multiply by 2. So under which P value I will look at it?
0.1.
Yes, I will look at it under 0.1. Do you know the reason why I am looking at under the 0.1? Because this table is designed for looking at the two-tailed situation. That is why. Right? Now, what is the value now? Somebody can read the value.
1.833.
1.833. Right. Now I am going to erase this part, right? Otherwise, we cannot continue. Right? You make a note of it. Right. Now the third step is decision-making process. Decision-making process. So in the decision-making process, can you remember if I say T calculated value, which is absolute value, is greater than the table value, right? Then we reject our null hypothesis. Right? Okay. What does it mean actually? What does it mean? Look at this distribution. This is, I'm talking about the T distribution. Right? So this is the area with alpha. This is 1 minus alpha. So here, this is a T distribution, right? We have converted into T distribution now. This is T distribution. We have converted this into T distribution. Clear? Right. So this is called as rejecting region. This is rejecting region. This is called as non-rejecting. So we discuss about rejecting region, non-rejecting region only in terms of null hypothesis. We are testing the null hypothesis. For example, if we reject our null hypothesis, we accept alternative hypothesis. If we do not reject our null hypothesis, that means we accept our null hypothesis, then what will be rejected? Alternative hypothesis will be rejected. So we can accept only one of the hypotheses, either null or the alternative. But always we are testing the null. We are testing the null hypothesis. So here also, this testing is based on null hypothesis. So rejecting region, this is non-rejecting region. So rejecting region is the region enclosed by alpha. Non-rejecting region means 1 minus alpha that we have seen. Right? So now, as you all know, in the T distribution, we have minus value as the minimum possible value. Maximum value will be plus infinity. Minus infinity and plus infinity. So now tell me this minus, let's say we can demarcate this value, table value. This table value is called as critical value. This table called as critical value. This T distribution, it always in this table, we always, because it is a symmetric distribution, we always look at the value. Always it is giving a positive value that can be used for the negative side, the other side also. It can be considered as the other negative value also, right? So here, because it is symmetric, 1.833 means this critical value is actually 1.833. So that what does it mean? Any value less than this minus 1.833 can be rejected. Any value less than minus 1.833 could be rejected. Is it clear? Any value less than minus 1.23 could be rejected. So that is what this critical point says. Right? How this minus value comes? In the table, you get always positive value, because here we are looking at the left tail. It is always a minus value, right? So we say minus 1.833 as critical value. Any value falling in this region, we reject. Now, can you tell me what is our calculated value? Minus 2.175. Can somebody tell me whether this minus 2.175 falling into rejecting region or non-rejecting region? Where does this our calculated value falls?
Rejecting region.
It is falling in rejecting region. Why? Because this is minus 2.175. This is here. So if I demarcate, it is somewhere there, right? So that means it is falling in rejecting region. Therefore, our decision is our absolute calculated value is greater than table value. We reject our number. This is the graphical explanation. You can, by looking at this also, you can make the decision. Either this or that is possible. We reject the null hypothesis. If you reject the null hypothesis, what is next? We have two hypotheses, null and the alternative. We are rejecting our null. Then what is next? We are accepting alternative hypothesis. Accepting alternative hypothesis or accept alternative hypothesis. So that is my decision making process. So this is my third step. My fourth step, I will have to do a conclusion. So in every research or every analysis, you'll have to come to a conclusion. So you'll have to give a conclusion. Conclusion has to be in a very softer manner where every layman should be able to understand the conclusion. So that is the purpose of all this analysis. So up to now, even layman cannot understand. Even a simple farmer cannot understand all these three steps. Only scientists or researchers will understand all three steps. That is more towards statistical computation. Right? So now we have taken a decision. We are going to reject our null hypothesis. Meantime, we are going to accept our alternative hypothesis. Right? If you accept our alternative hypothesis in simple terms, can you tell whether that water can be used for irrigation or not? Can you tell me whether that water can be used for irrigation? In a simple term, because we are accepting our alternative hypothesis. We are accepting our alternative hypothesis. So in a simple form or simple term, can you tell me whether we could use this alternative hypothesis? Anyone? Some chats are there. We can use the water. Somebody has written, we can use the water for irrigation. Can we? I'm asking from you. Can we? So my alternative,
Yes.
yeah, my alternative, I accept my alternative hypothesis mean we are come to a conclusion that the average EC content of the water is less than 3 microsiemens per centimeter. So if it is less than, if we come to a conclusion that, because accepting H0 mean, sorry, accepting H1 mean, what is our null and the alternative? What is our null and the alternative? The alternative says we are accepting our alternative hypothesis. Alternative says mu is less than 3. So that means the average EC content of the pond water is less than 3 microsiemens per centimeter. Right? So that is our conclusion. If it is less than 3, can we use that for irrigation or not? Yes, sir. Yes, we can use that for irrigation. That is the testing. Look at the question, whether that water can be used for irrigation. Whether that particular water can be used for irrigation. Yes, that can be used for irrigation. Right. So what is my conclusion? Water could be used for irrigation. Water could be used for irrigation. So this is, now you see, all the rest of the 3 steps are more statistical oriented, where farmers doesn't know what is happening. Farmer need this information. Whether that water can be used for irrigation or whether that water cannot be used for irrigation. So ultimately, this farmer understands that water can be used for irrigation. So farmer can make use of water for irrigation. Right. Any questions on that? So that is the answer. So if you write all these steps, you will get 100 marks. If you miss some of the steps, you will lose some marks. Any questions? So always, you don't need to write all these 3 steps one by one, but we'll have to have all these 4 steps incorporated. Hypothesis, null and the alternative hypothesis, test statistics, decision making process, and the conclusion. Any questions? Right, we can have a confident interval also. So if I ask construct 95% confident interval for the true mean, true mean of the EC, electrical conductor. So simply, I'm going to construct 95% confident interval. You can use the previous formula, x bar. What is the x bar here? What is the x bar? 2.87. 2.87 plus or minus t alpha by 2 n minus 1 into S, which is 0.189 divided by square root of 10. Right, how to look at the table here? How to look at the table? Here the table says alpha by 2. Once you look at alpha by 2, it is a one tail or two tail? Alpha by 2, is it a one tail or two tail?
Two tail.
Two tail situation. So if it is a alpha by 2, two tail situation, we never go for alpha one tail situation for confident interval. Confident interval, no point of having one tail. We always go for two tail for confident interval. Right, now tell me what is the table value from this table. Already I said this table is designed for two tail situation. Anyone? Anyone? What is the value? T value. What is the t value? Table value. This is for two-tail situation. Yeah. This is for two-tail situation. Tell me. Shalomita, tell me what is the value? This is for two-tail. Directly look at the alpha value from the p value. Look at the value 0.05 and degrees of freedom 9. What is the answer? What is the answer?
$2.262.
Yes, 2.262, because here we can write this is 2.87 plus or minus 2.262 into 0.189 divided by square root of 10. And somebody work with this value and tell me what is the answer for that. Very quickly. What is the value? What is the value? Anyone?
$0.03 to 0.3.
No, no, I'm asking only this value. Only this calculation of this value. Only this value. Anyone? I'm asking only that value.
0.133.
Right? Okay, 0.136. So that means the lower value and the upper value in between. Let's say the upper value is 2.87 plus 0.136. The lower value
133.
133. Okay. The lower value is, sorry, the upper value is 2.87 plus 0.133. The lower value will be 2.87 minus 0.13. Right? Now tell me the range of value. This is roughly about 3. Roughly, let's say 2.74. So the range is in between 2.74 to 3.03. We can say you are 95% confident. The answer is you are 95% confident that the true mean EC value, you are 95% confident that the true mean EC value range between 2.74 to 3.0. We have to calculate this value very perfectly, otherwise this will mislead. Right? 3.0. So you are 95% confident, right? You are 95% confident that the true mean EC value. You are 95% confident. You are rather than saying you are, I am 95% confident. I'm 95% confident that the true mean EC value range between 2.74 to 3.03 decisiemens or microsiemens per centimeter. So that is how you have to answer. Right. Now, very quickly, all of you are there. Right. So you see here the alpha is 0.05. Number of sample is 60. Here alpha is 0.025. Number of sample is again, let's say not 16, we'll say 20. Number of sample is 20. Right? Let me check. Look at the chat. Number of sample is 20. The second place. What is third step? I didn't understand. We will stay. What do you want, Eleni? What's third step? Eleni,
Calculation, third step.
what is that?
In previous calculation, third step, sir.
Yeah, in EC calculation. Electrical conductivity calculation.
Yes, sir. Only third step. Decision step.
Yeah, decision making simple. Now we have distribution, T distribution, the value is 0 here. The value is 0 here, right? This is the T distribution. Then, as we already know, this is the rejecting region. This is non-rejecting region. That from the theory, right? Rejecting region and non-rejecting region is from the theory. Now we want to find out what is this critical value. That we can find out only from the table, right? Our calculated value we already know, that is 2 minus 2.1 something. I can remember 17, whatever it is. I will say 2.17. Clear? Right. So this is my calculated value. Easy. My table value, I look at from the table. So when you have the table, I said this table is designed for two-tail situation. But here we are talking about one-tail situation. If it is one-tail situation, you have to multiply the alpha by 2 and look at the table. So we'll have to multiply the alpha. Alpha is 0.05 in this example. Multiply by 2, which is 0.1. So look at the p-value for 0.1 with the corresponding degrees of freedom 9. So you will get a value 1.83. You will get a value 1.83. So this is less than 0. So this should be minus, is it? If it is less than 0, it should be minus. I can say this is 1.83 plus. I can't say because if it is plus, it should be on the right side. So this is a symmetric. That is what I said. You can look at the table for both values because it is symmetric. Right. Now tell me, Tilini, where this value comes. Whether this value coming within this shaded area or non-shaded area. Value.
Shaded area.
Yeah, shaded area. Shaded area, what it says is we reject our null hypothesis. Shaded area says we reject our null hypothesis. That is the rejection rule, right? That is the rejection rule. So, since this is falling into the shaded area, we reject our null hypothesis. We reject our null. So, if you reject our null hypothesis, what is the other step? We'll have to accept our alternative. If we reject one option, the other option is the correct one. So the correct one is the mu is less than 3. Then the rest of the decision and the conclusion made based on it. So this is how we.
Thank you.
Yeah.
Okay, sir. Understood.
Okay. Right. Very quickly, those who are already in, this is a simple quiz. I'm going to give a quiz. I will wind up simply by saying in the program. Once it in the program, you cannot submit again. I will give the time. I'm going to give 30 seconds or maximum 1 minute. I'm going to give 1 minute to answer this question. Right? Right? ஒரு நிமிஷம் தரணும் நீங்க ஆன்சர் பண்றதுக்கு நீங்கள் ஆன்சர்ஸ் எல்லாம் chatல அனுப்புங்க. You'll have to send the answer by chat. විනාඩියක් දෙනවා. Right? උත්තර ටික chat එකකින් යවන්න. Right? Okay? In 1 minute time, I will end the program. Thereafter, you cannot send the answers by chat. Is it clear to everybody? I didn't ask the question yet. Is it clear to everybody? Send through chat. I can get the printout from the chat. No problem. Every name, for example, Arosha AG1131. What is the answer? Automatically it comes in the computer. Don't forget that. Everything is there. Next time I will show you. Right? So this is one way I can get the attendance. Right. The question is this. You can't send the message. I mean, you can't send. Don't send the answers to others. I will give exactly 1 minute. So now tell me t value if it is, what is the t value? If it is one tail and two tail, right? So here, 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 here. If it is one tail, two tail, what are the answers? You'll have to send by chat. By looking at the table. You'll have to look at the table. By looking at the one tail and two tail. Give all the answers at once. Don't give answers one by one. So if let's say one person giving, what is the answer for this? 4 answers should be there in a sequence. This is answer 1, answer 2, 3, 4. So write like this and send it to me. That is easy. You have another 45 seconds.
Sir,
Yeah.
sir, now I am joined. I miss from electrical conductivity part. Power cut in my area.
Okay. At the moment, I cannot do anything. We will see next time because, yeah. You send the name who has the power cut by chat, so I can record it. දැන් power cut කියලා කතා කරපු එක්කෙනා chat එකෙන් දාන්න නමත් එක්ක power cut එක. Then I will see what are the possibilities I can do. Mm. 15 seconds more. Huh?